R2 is equal to R3 by R4. 8 by 4 is equal to 20 by 10.
Don't apply if you are not studying about the Wheatstone bridge measurement and apply KCL, KVL to solve a particular circuit. Okay.
Okay, ma'am.
All of you, please take down the circuit. You are having time till the others join. You can try it on your own. You are to apply KVL either by writing equation or direct inspection. You are free to do any method. You are to obtain the three currents I1, I2, I3. Here they themselves have assumed the clockwise direction of current, so you cannot assume any way around otherwise. So try to solve the problem. Are you people trying it out?
Ma'am, you have to solve for I1, I2 and I3.
Yes, by KVL, by
Okay.
applying mesh analysis, direct inspection. Anyway, you can solve. Okay, by writing equations, if you want to solve means you write. Or otherwise, by direct observation, direct inspection matrix method also, if you can solve. You are free to use any method. Come on, I will handpick anybody to give me the answer. Step by step. So all should try to solve. This will be the last class that I am spending on KCL KVL.
Ma'am, can you repeat what we have to do?
There is some circuit that is present now in the slide.
Yes.
You are to apply KVL, okay? KVL, you can either write equations or otherwise you can apply direct inspection matrix method to find out the currents I1, I2, I3.
Okay.
Come on, also try to solve. I will pick out everybody
I1 is
and
equal
ask
to,
step by step.
ma'am, I1 is equal to 1.125 ampere.
See, I have not even started to work out the problem. There are 37 people. I told you don't rush up in giving answer straight, the last answer. There is a step-wise procedure that you have to proceed, isn't it, in order to get entire 16 mark. Simply people jump to the last answer I1 is equal to. If you solved, if you got the answer, well and good. Wait till the others also give the answer. Okay, Varun. On all the others also finished. Shall I ask questions from your side? Come on, for this problem, you are to use KVL to find I1, I2, I3. That is a problem statement for you. Okay, Aryan, tell me in what way you are solving the problem. Aryan.
I'm using KVL and KCL equation in the loop.
Only KVL I have asked you to use. How you are using KCL? You are using
KVL
direct
only.
inspection. Okay, you are using direct inspection method or you are writing equations?
Direct inspection method.
Okay, then tell me the matrix that you will have.
I'm
The
doing
matrix
only.
will be... No, whatever you did, you tell me. What are the voltage elements? There are how many meshes here?
Two meshes.
Only two meshes you can observe. Here there is mesh number 1, mesh number 2, mesh number 3. There are how many meshes actually?
Three meshes.
Then there should be three voltage elements V1, V2, V3. Tell me what are they? Ayush. Ayush,
Yes, ma'am.
tell me what are the voltage elements for the first mesh.
First, I'm 24.
Yes, if you follow the current direction, it is going from minus to plus, so you should give plus 24. What about the second mesh? Are
Mm,
there any voltage sources in the second and the third mesh?
no, ma'am.
No,
So
ma'am.
you will write 0 and 0. Okay, so this finishes off your voltage matrix. Then comes your I1, I2, I3. Okay. Now how will you write R1, 1, R1, 2, R1, 3?
Mm,
What is your R1, 1? Agarwal. Akhil Vanam. Agarwal. Akhil Vanam and Agarwal.
Yes, ma'am.
Tell me what is R1, 1? That is sum of the resistances that are present in the first mesh. That is R11, R22 is sum of the resistance present in the second mesh. What is the value? What are the resistances that are present in the first mesh?
12 ohms, 8 ohms, and 20 ohms.
What is the sum?
20, 40.
40. 40. Then what is R12? The common value of resistance between first and the second mesh.
First and second, 8 ohms.
Between, then you have to give what sign for it? Minus 8. Okay. Then what is the common value of resistance between 1 and 3?
20 minus sign.
So you have to give a
Plus
minus
sign.
20 sign. Okay, enough. Okay. Now, Chinmay, tell me what is R21, R22, R23. Chinmay, Chinmay,
Hello.
what is R21, R22,
R21 is 20.
R23?
R21 is 20.
R21 is minus
20.
20.
Minus
Then
20. R22 is 8,
R2,
4, and 6, 18.
18. Then R23,
And R23 is 6,
6 or minus 6.
minus 6.
Okay. Then next, third mesh R. Okay, I will ask somebody else. R31.
Ma'am, how R21 is minus 20? It should be minus 8, na?
R21 now.
Yes, ma'am. It is between 2 and 1, na?
Ah, okay. Yeah. Okay. Okay, this is R21. So between these two meshes you have to see that is 8 only. So it's correct. So I'm rewriting 8 minus 8. Okay, now it's correct. Huh? Take
Yes,
care while writing resistances. Okay.
Okay.
Come on. Now regarding the last mesh,
20.
R31, R32, R33.
Now shall I continue?
Yeah, you tell.
Now R31 is 20. Minus
Right.
20, and then
R31 is minus 20. Yeah. Okay. Minus 20. R32.
R32 is 6, then minus, and R33 is 10.
R33 is how much?
36. No, man, that 20 and 30 and 36. Sorry.
36.
All have written this matrix. All is correct. Come on, others also in class. Is it okay? Okay. Now the next thing is you need to find out determinant, determinant 1, determinant 2, determinant 3. Then you have to divide del 1 by del to get I1, del 2 by del to get I2, del 3 by del to get I3. So you will move on to the next slide. I will cross check with the answers. So easy way to cross check this is these two values should be equal. Okay. And these two values should be equal. Alright. And these two values should be equal. Just to check it out. Okay. R21 will be equivalent to R12. R31 will be equivalent to R13. And then R23 will be equivalent to R32. Like that. Okay. Only these diagonal elements will be varying. That way you can cross check. Alright. Now let me 4828. Let me check up with the answer.
Ma'am,
Okay. What?
ma'am, if we do it without mesh analysis, can you explain this because and using the current is not passing through the system.
What ma? Ask again.
Ma'am, if we use Wheatstone bridge method, the current won't
See.
pass through the 6 ohm resistor.
Why you are mixing up your Wheatstone bridge methodology with electric circuit analysis? Both are different subjects, so you are not supposed to mix anything. Alright. I am giving you one circuit. I am asking you to solve it by KVL. I am not asking you to apply Wheatstone bridge methodology, bridge balance and all. I am not asking you to use up. Then what's your doubt? Don't think too much, okay? All I will do is I will give a circuit. I will ask you to analyze. I will ask you to obtain some parameters in the circuit. I am not asking you to apply the Wheatstone bridge cross checking and all. I am not asking you to balance the bridge, okay? Don't go too much, okay? Don't think over, alright? Whatever is given to you, solve it, okay?
Yeah, okay.
See, now this problem they have solved it by some other method. Let's skip that method. We will solve it by our own methodology. So what was the matrix? Tell me. What is del? Again you tell me. Del. Just now we have written del law. What is del? I think they have divided everything by 2. See, Mudimala, mute your mic when you are not supposed to answer. Please mute your mic, otherwise it is an interference to everybody. Okay, so 40 I think, 40, then what was the second element?
minus 8.
Minus 8, and minus 20, yeah. What is R2 to
18.
18? R23, 6,
Minus
Then what about R33? 36,
36.
Okay, tell me what is the del value. You are having calculator now? Calculate it and tell me.
13056.
All got 13? What is the value?
056.
13056. All got 13,056. Jaypraveen Reddy is not understanding.
How
Praveen.
it should be 29,376.
Yeah, ma'am. I'm new to
What is the answer? You are to tell me. What answer others are getting? I am not knowing the answer. You are to tell me. What is the answer others are getting? Which one? You tell me, Ashwant, what is the answer that you got? 20?
Ma'am, it is 29,376.
No, ma'am, it is
Among these two?
13,056. Ma'am, I'm getting
Okay.
15.
Okay, wait,
You
let
must
me
have done
check.
one mistake.
Let me check the answer with others also. Okay, you also cross check. Others, what answer are you getting, ma?
Ma'am, I'm getting 15936.
What all are getting different answer? You try it correct.
13056.
Ma'am, I got 14976.
All are giving me different answer, man. Try it for correctly. Don't do it wrong. You know how to proceed with the determinant calculation now.
Hello? Ma'am, I
Let me
checked
ask from some girls.
calculator.
Only three people are giving me answer. All are different. Then how can I cross check men? Okay, I will ask from some girls. Samyukta, tell me what answer are you getting?
Ma'am, what is value of I1?
I do not know. I have to check. Wait.
Okay, ma'am.
I1 is 5 by 4 they have given. 5 by 4. I think 1 point something you will get.
1.25.
See, rest tell me the answer. What about Samyukta? I asked something from
Ma'am,
Samyukta.
13056 is correct. I have checked.
Ma'am, 13056.
Ma'am, from Del 1 also it is, I am getting correct value of I1.
Okay, so you are telling 13056. What about the rest? Samyukta? Joshua Nathaniel? Reshma? What's the answer that you are getting? There is no answer from Samyukta. I don't know what she is doing. Reshma?
Ma'am, 1 second.
Vaibhav, tell me the answer. What answer are you getting for the determinant? Vaibhav?
Ma'am, I've just joined the class right now, just before 2 minutes.
You should have seen the previous class videos, no? Then how will you understand the continuity?
Yes, ma'am. It's very important for me. Yes, ma'am.
Okay,
Ma'am,
no
I'm getting
problem.
the same
Same.
answer.
Ma'am, can I say the answer?
Yes, tell. Rashma, what is your answer?
Ma'am, 24,072.
Okay, most of you people are getting 13,056, so I am going to stick with 13,056. What about Ishika? What is your answer? Ishika, Samyukta, no answer from these two girls. All the others are trying, or you are simply sitting there? What about Prabhas' answer? Rajdeep? Come on, I want to know whether you are trying or you are sitting simply staring at the screen. Okay, I'm going to stick with let me check the answer finally, okay. So what is my del 1? Del 1, first column I am going to replace by what? The voltage elements. So 24, 0, 0, minus 8, 18, minus 6, minus 20, minus 6, 36. So find out del 1 also and then del 2 too.
14,688.
14,688.
14,000.
688.
Yes, ma'am.
88.
14688.
So del
Yes, ma'am.
2.
And determinant is 13056.
Okay.
Ma'am, I had
The
done mistake
second
over here.
column,
979.
9792.
del 2. Del 2,
9792.
what is your del 2?
9792.
9792.
9792.
Del 2 is 9792.
792.
What about del 3 in the same fashion?
Ma'am, del 3 I haven't calculated yet.
Del 3,
Nines.
what is del 3 value? 2400 and 40 minus 820, 40 minus 8 minus 20, yeah? Minus 20, 28, 18, 6.
9648.
What is del 3?
9648.
All are getting 9648, others?
Ma'am, 9792.
What about others?
Ma'am,
Ma'am,
9792.
9792.
Okay, 9792. 9792. Check your answer, Ishma. Okay, 3 answers you got. Now we will finally summarize. What is del? Del 1, del 2, del 3. Tell me the answer. 13,056. What is del 1?
Ma'am,
14,688.
14,688.
14,000.
688.
14,688.
What is del 2?
9792.
9792.
Then del 3?
9792.
9792.
Del 3 is also same answer.
Yes, ma'am.
Yes, ma'am. Del 2 and del 3 are same.
Okay, now what is I1? I1 is equal to del 1 divided by del, that is equivalent
Del.
to 14,688 divided by 13,056. So what is my
Which is
I1
equal to
current?
1.25.
Ma'am, 5 by 4.
1.25.
1.25.
1.25 ampere. I think that answer is correct.
Ma'am, 125.
Okay.
1.125.
1.125.
Okay, 1.125. Alright. All got this answer 1.125 ampere for your I1.
Yes, ma'am.
Okay, what about I2?
0.75.
0.75. I2 and I3.
0.75.
Del 2 divided by del is a formula. So 9792 divided by 13,056. What is the answer for I2?
0.7.
0.75.
0.75.
0.75 ampere. Okay, what about I3 then? I3 also same answer, I think you will get. So values are set.
Same answer.
All got this answer 1.125 and 0.75 ampere.
Yes, ma'am.
Yes, ma'am.
The remaining people, what about Samyukta? No answer. Rishi, are you trying? You got the same answer?
Yeah, ma'am, same answer.
What about Kushoni?
Yeah, ma'am, I got the same answer.
Okay. Then Karthik, Ishika, madam.
Got the
You got the answer?
yes, ma'am.
When I was calling you, you were silent. You were not responding. Why?
Network issue. Ma'am, my call is being disconnected.
What about Samyukta? Okay, no problem. But you got the answer, huh?
Yes, ma'am.
Okay, all got the same answer, I am hoping. We'll move on to one KCL problem also. KCL problem will move?
Yes,
Or
ma'am.
do you want me to wait till you finish up? Okay, we'll move on to one KCL problem, okay. See, those who are new to class, Vaibhav and Jay Praveen, just try to go through the previous class videos. Okay, first you do that. After watching those videos, in case if you are having any doubts, you can contact me. Okay. Praveen
Okay, ma'am.
and
Through
Vaibhav.
WhatsApp.
Okay, ma'am. Okay,
You got what I am telling you? Yes. First you watch the videos. It will be, if you are not able to understand from those videos, you can call me anytime.
Okay, ma'am. It will be available on GCR, na?
Okay, ma'am.
Yes.
Okay, ma'am.
Okay. Now for the rest, there is a circuit again given in the problem for which you have to apply KCL and you have to find out the nodal voltages VA, VB, VC. That is the question. Try to solve in the same way. You can write by using equations or you can use direct inspection as usual. But here they have did one technique, that is source transformation. What did they have did here? Tell me. There are two circuits actually. You have to apply KCL here and you have to find out the nodal voltage at A, B and C. Okay, that is your question. And here you can see there is a voltage source in series with 4 ohm. That they have converted into what here?
Ma'am, parallel one. Because we have
Yesterday I taught you one technique, no?
current source we have
Yes, this technique is called as what?
source
This technique is
transformation.
called as what technique?
Source transformation.
Source transformation. Okay, so yes, V is given to be 12 volt, R is given to be 4 ohm. So they have found out current by V divided by R. So that is 12 divided by 4. That is equivalent to how much? 3 ampere.
3 ampere.
They have connected the resistance in parallel. Okay, this technique they have used to convert the voltage source into a current source. That way it will be easy to write down the matrix. For that purpose only they have used source transformation. Okay. Now you write the matrix method or write equations and solve for VA, VB, VC. All are trying to do, no? This time also I will ask answers from others in class, okay? So try to solve it. You are to use KCL to find out the nodal voltages VA, VB, VC. That is your question. You can adopt writing equations or direct inspection, whichever way you want to solve, you can use. This time I will get answer from Dhruv, Shrish, Dhanush, Rahul. Initial classes all were responding very nice. Now all have gone silent. Rahul, Dhanush,
Excuse me, ma'am.
Dhruv.
Yes, ma'am.
Yes.
Excuse me, ma'am.
Now the answers I will get from your side, Dhruv. Yes, tell.
After the source transformation, why
Tell Ma, Mohan. Why are the what?
why are all the resistance and
Half. Resistances they have taken what? Half of the question only I am able to hear. The remaining half I am not able to hear.
Ma'am, the resistance is inverse, right? So why was it taken like that?
No, it's the way you write matrix, you will be taking the reciprocal. No, so that's why they have taken like that. Okay, you keep it as 2. Okay, well, writing matrix, you will be using 1 by R only now.
Okay.
So in order to make it simplify the manner, they have written it as 1 by 2 mho. The inverse symbol is mho. Okay, that is conductance only.
Okay.
Understood, Mohan? Come on, Dhruv, Dhanush, Rahul. Between you three, the answer should come. Rahul is silent.
Yes, ma'am. Yes, ma'am.
Dhanush is silent. Dhanush. Dhanush.
Yes, ma'am.
Answer should come from your side. Dhanush, Rahul and Dhruv.
Okay, ma'am. Okay, ma'am.
Sai Gokul. Sai Gokul. If you have written the equation, tell me the equation, ma. Dhruv, Dhanush and Rahul.
Starting.
Here you will be writing I is equal to V 1 by R. Like this you will write. What are the current elements? There are 3 nodes, 1 reference node, A, B, C. What is the current source at A node? How many current sources are involved?
2 current sources.
Okay, so 2 current sources are involved. So this one is entering 3 ampere and this one is leaving. So 3 minus 9. Okay, so what is the value?
Minus 6.
6.
Minus 6.
Minus 6, huh?
Minus 6, madam.
Okay,
However, it
so
indicates
that
the
is
opposite
over.
side.
Then what about this
Yeah.
node? Which is indicating opposite side? One is
The minus,
entering, one is leaving. So I have given a negative sign for leaving current.
Oh, okay, ma'am.
Minus 6 only. So what about the current at B node? Current source at B node.
6.
B node, are there any current sources involved? B node, are there any current sources involved?
0.
No current source, ma'am.
0. What about this node C?
1 minute, ma'am.
9.
9. Okay, 9.
Ma'am, I don't understand.
Okay.
Why 9?
All right.
Why 9?
Ammeter is connected.
This current is entering, no? 9
Yeah,
ampere is entering, no?
yes, ma'am.
Okay. All right. Then we are done with I matrix. Now, how many voltages are you supposed to find? VA, VB, VC. That is unknown, X factor. Now we need to write 1 by R11, 1 by R12, 1 by R13, 1 by R21, 1 by R22, 1 by R23, 3 cross 3 matrix it will be. So 1 by R31, 1 by R32, 1 by R33. Okay, alright. So this will finish up the matrix form. So what is the matrix? Tell me, shall I rub it?
Yes, ma'am.
Use a different page, minus 609.
VB, VC.
VB, VC.
Multiple.
Okay, what is 1 by R11?
Ma'am, can you just change the page?
Okay, tell me, what is 1 by R11? All the resistances that are connected to this node, okay. So 1 by
4
2
plus 1 by 2
plus 1 by
plus
4 plus 1 by 4. Okay, so what is 1 by 4 plus 1 by 4 plus 1 by 2. 3
Yes,
resistances are connected, no?
1 by 4.
Okay, so what's the answer? 1 by 4 plus 1 by 4 plus 1 by 2. That is your
1.
Okay, then what about R12? Dhruv. R12 common between A and B. Between these two nodes, what is common?
1 by 5 plus 1 by 2, no?
Why 1? Not 1 by
Where
5.
is 1 by 5? 1 by 5, 5 is connected to B node only. How is it? Where there is 5 ohm? Here only there is a 5 ohm. That is connected to B and C. How is it connected to A?
Okay, ma'am.
Okay, yeah. Okay, so between A and B, from Rahul's side, so much background music is there. Okay, so A and B, what is the common value connected?
1 by 2.
1 by 10, madam.
1 by 10, no? Where is 10?
1 by 2.
1 by
1 by 2.
1 by
1
2.
by 2.
1 by
What is the sign that you will give? Minus sign. Okay. Then
Ma'am, always we have to
between
give
1
minus
and C, even while writing equation, you will get negative sign only. Okay.
So, ma'am, always we have to write with
Okay. So
minus sign
between
only.
A and C. Yes.
Zero.
If you are assuming same direction of currents, otherwise, no, there is common one resistance. No, check the circuit
Ma'am, 1 by
properly.
4.
1 by 4.
1 by 4.
This is connected between A and B. So what will be the value here? Minus 1 by 4. Okay, so next, what is R2, R21, that is RBA,
Minus 1 by 2.
RBA, again minus 1 by 2. Okay, so what is RBB?
Minus 1 by 2 plus minus
To this value, what are the resistances connected? This one is connected, this one is connected, this one is connected.
1 by
So what will be the
1 by
value?
5, 1
5
by
plus 1
10.
by 10.
Tell me, 1 by 2
2
2, 1 by 5, 1 by 10.
plus 1 by 5
1.7
plus 1 by 10.
Plus 1 by 10.
10.
Okay, then between B and C, what is common?
minus 1 by
5.
5.
Minus 1 by
1 by
5.
5.
Minus 1 by 5. Okay, then again. Okay, but what is CA? RCA again?
1 by
Minus 1
4.
by
1 by
4.
4.
Minus 1 by 4. RCB?
Minus
Minus
1 by
1 by
1
4.
by
7.
5.
RCC?
1 by 5 plus 1 by 20.
Plus
1 by
1 by
20
4.
plus, that's all, 1 by 4. Okay, that's all. Okay, now you calculate the determinants and VA, VB, VC as usual by applied Krebs rule. And tell me the answer. I'll cross check the answer. Anybody calculate the
Yes.
determinant?
Starting one.
Samyukta,
Ma'am, may I tell the
Samyukta,
answer?
where is? Tell.
Ma'am, del equals to 27 by 200.
Don't tell fraction. What is the answer? 27 by 200.
Ma'am, give me a second.
Ma'am, 0.135.
Okay. 0.135. Correct, huh? Del is 0.135.
Ma'am, del 1 is
Yes, ma'am. Correct.
0.54.
Del is 0.135. All got 0.135?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Rest also. Give me an answer. Same way how to do for del 1. Okay, how to replace the first column by voltage elements. What is a matrix? You can tell me in a reduced manner. Could you? Otherwise tell me the answer directly. Because I don't know the value memorized.
Ma'am,
Okay.
0.54.
0.54. Del 2, del 3.
Del 2 is 1.125.
Del 3. Yash. Yash is doing the problem. What's the
Yes, ma'am.
answer? Del 3. Utsav Anand.
Del 3 is 3.15.
3.15. Come on, check up the answers others in class. Are you getting the same answer? You tell me. Piyush, Utsavanand,
Ma'am, I'm calculating del 3.
other answers are correct?
Yes, ma'am.
Utsavanand,
Yes, ma'am.
are you doing? Have you got the same answer?
Yes, ma'am. Yes, ma'am. Yes, ma'am. I'm calculating del 3.
I'm hoping all get the or got the same answer. After this, you have to calculate VA. That is by using del 1 divided by del, that is 0.54 divided by 0.135. And VB,
4,
that
madam.
is del 2.
Ma'am, VA is 4, ma'am.
4 volt. Okay,
VA
4
4,
volt.
ma'am.
VB, 0.125
8.3,
divided
madam.
8.34 volt.
8.3.
8.3 volt. Okay, what is VC?
23 by 3. 23 by
23.3.
3. 23.3.
Okay, VC is 23.3. Ah,
23.
Yes, ma'am.
all got this answer?
Yes, ma'am.
Yes,
4,
ma'am.
8.3, 23.3. Okay, so we'll proceed to the next topic, theorem. So remember one more thing, even though direct inspection method is very easy for you to solve, still you should know how to write it in terms of equations and obtain the same answer. Okay, sometimes they will expect you to write equations and solve. They will ask you to write down KCL equation, KVL equations, and they will ask you to solve. Okay, that time you should be ready. Will you do it?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, shall we proceed to the theorems section? Because next experiment is all about theorem. So I
Yes,
want to
ma'am.
give a short introduction.
Yes, ma'am.
All have solved this problem? You understood it well?
Yes, ma'am.
KCL, KVL, mesh analysis, nodal analysis.
Yes, ma'am.
Yes, ma'am.
Okay. So we'll move on to the theorem. Okay. Just I will discuss only one theorem. Small intro with a small problem I will tell. Okay. All right. Okay, statements of all the theorems are very important. Like you are learning how to state KVL, KCL, the statements of the theorems are also an important question. Okay, so what does the statement say? There is a statement, no statement of Thevenin's theorem that is given here. So what is the statement? Tell me.
Any
question.
linear active network.
What does it say? Any linear
Single
active
voltage
network
source.
with output terminal say B can be replaced by what?
Single volt.
Can be
By a
replaced by a
single
single
voltage
voltage
source.
source in
With
series
single
with
impedance.
single
With output
impedance.
terminal say B can be
Impedance.
replaced by what equivalent? Single voltage source in series with what?
Single impedance.
Single.
Single voltage source in series with the single impedance. Okay, that is the statement for Thevenin's theorem. They will give you again some
Linear.
circuits. Yes, and they will ask you to find out the Thevenin's equivalent. So let's see. Suppose if this is your linear active network, any network, suppose if it is having so many resistors like this. This is a linear network, okay. Suppose if you are having such a circuit, you can find its equivalent, a simplified one, which consists of what here? This circuit. This circuit is very simple when compared to the earlier complicated circuit that I have drawn. Now you are having only two elements in that reduced network. What are the two elements that you are having?
Resistor and
One is VTH. VTH is called as Thevenin's voltage. Okay, Thevenin's voltage or open circuit voltage. Okay, you remember this factor? V Thevenin is called as what? V Thevenin is called as Thevenin's voltage, otherwise called as open circuit voltage. Okay, OC means open circuit. So open circuit voltage or Thevenin's voltage is represented as V Thevenin. Okay. Now you are what, ma? Now it's okay, I think so. Okay, now what is V Thevenin? It is written on the slide. V Thevenin is called as what?
Thevenin's voltage.
Open.
What is V Thevenin? V Thevenin is Thevenin's voltage or OC voltage. OC voltage means open circuit voltage. Okay, that is, yes. It is connected in series with what? That voltage.
Impedance.
This voltage is connected in series with what?
Impedance.
Z is generally representing impedance. Okay, impedance. So this is called as Thevenin's impedance. Okay, Thevenin's impedance. Okay. So what way will you be able to state Thevenin's theorem now? Tell me. Suppose if you are given with a complicated linear network, then it can be reduced into a simple circuit which consists of only two elements. What are the two elements that the circuit will have?
Thevenin's voltage and Thevenin's impedance.
What are the two elements the circuit will have? One will be the VOC or V Thevenin voltage that will be connected in series with Thevenin's impedance. Okay, Thevenin you will be able to. So what is Thevenin's equivalent? What is Thevenin's equivalent, ma? Suppose if you are having a big circuit with so many components in it, any linear active network, that can be reduced into a simplified circuit having one voltage source connected in series with what?
Thevenin's volt.
Thevenin's voltage source or open circuit voltage that will be connected in series with the Thevenin's impedance. Okay, suppose on the other hand, if you are reducing the same circuit by means of a parallel equivalent like this is called as ISC, again this is called as Z Thevenin. Okay, so here what you are having? ISC represents my current source or voltage source?
Current source.
Current source, man.
Current source.
Current source. So this is called as short circuit current source. Okay. Short circuit current source that is connected in parallel with what? Connected in parallel with one?
And we don't know.
Is that means always
Thevenin's
Thevenin's
impedance.
impedance? Is that means
Thevenin's impedance.
Thevenin's impedance? Okay. So this circuit is, yes, this is called as Norton's equivalent. Okay, Norton's equivalent. Alright.
Will you please pardon?
Norton's equivalent and Thevenin's equivalent.
Okay.
Ma'am, will you be
Ma'am, when there is voltage source, it is Thevenin's equivalent.
Yes, yes. This circuit shows a
When there
voltage
is
source.
current
This
flow.
source is called as OC. Okay. Thevenin source. That is in series with Z Thevenin. This is called as Smith Thevenin's equivalent. Okay, this is called as Smith Thevenin's equivalent. Suppose on the other hand, if I am representing it by one current source in parallel with Z Thevenin, then that will be called as what circuit? This will be called
Norton's
as
equivalent.
Norton's equivalent. So accordingly, you will be having two theorems. One is Thevenin's theorem and another one is Norton's theorem. Okay. Understood what are the theorems? Thevenin's and Norton's theorem. Okay. Now, how to solve this, I will tell you one by one simple example. Now, you understood now what is Norton's equivalent and what is Thevenin's equivalent? Yes or no?
Yes, ma'am.
Okay. Now, they have given one diagram, okay, and they have asked you to determine the current in the network by using what theorem here?
Thevenin's theorem.
Thevenin's.
Yes. They have asked you to find out the current through this 10 ohm by using what theorem?
Thevenin's theorem.
Thevenin's.
Thevenin's theorem. Okay, Thevenin's theorem. So in order to do this, first step is you need to find out VOC. What is VOC? VOC or Thevenin? What is VOC?
Open circuit
Open
voltage.
circuit voltage or Thevenin. So between what two terminals current flow is asked as per this problem? Current flow is asked between what two terminals? There are terminal markings. No, A and B. Okay. Through this only the current is asked in the problem. Okay. So what you need to do is, first thing is you have to open it. Okay, this part you have to open. Wherever they have asked you to find out one parameter, that parameter terminals you have to open. Okay. You open it and then you find out what? What is the thing that you have to find? Open circuit voltage. Okay, then next thing is you need to find out R Thevenin or Z Thevenin. Okay, what is Z Thevenin or R Thevenin? R generally represents your impedance or resistance. So this Thevenin's resistance you have to find. Okay. So for finding it, there is a particular procedure that you have to follow. Now, what are the sources that are present in the system? How many sources are there?
Two.
So, two voltage source you are having. Here you are having one source, here you are having one source. So, these sources should be killed. Okay. These sources should be killed. Killing means, suppose if you are having a voltage source, you have to short it. Okay, if you are having a voltage source means you have to short it. Current source means you have to open. Okay, current source means you have to open, voltage source means you have to short. That is what is called as killing of source. Okay, then you have to do this, then you will find out R Thevenin by looking from the AB terminal. Okay, this is the procedure. First thing is, you will be opening the terminals across which you have been asked to find out the current or voltage. You will find out VOC. Next thing is you have to kill all the sources. Killing sources means what do you mean?
Short.
Short means what sources will be short?
Voltage source.
What sources you will open? Voltage sources you have to short.
Current
Current sources you have to open. Okay. Draw the circuit again. Then you will find out RThevenin by looking from the back side. Okay, from the terminal marking. That is what we would have did. Let us proceed with the problem. After which you can close class. Okay. Now, as I told you, this is a circuit. And here you have to find out the current through this 10 ohm resistance. So you are going to open it. Okay, open the terminals and you have to redraw the circuit. You can check it out. What they did it here? This circuit.
Open.
They opened. There was one resistance here. There was one resistance here that they have opened. Okay. Okay, and then they have to find out what value.
Current.
You have to find out what voltage.
Open current voltage.
VOC.
Thevenin's voltage you need to find. Okay, Thevenin's voltage you need to find. So there is a loop, mesh forming 4, 6, 10, 12. So in this mesh, they will be writing down KVL equation. Then they will find out I. Using that I, they will calculate whatever may be the voltage appearing across this terminal. Okay, you have class or no? 11 o'clock, what is your class, sir?
No, ma'am.
Okay, then we will solve this from 12 o'clock, yes, let us solve this problem and then you will go, or let us continue in the next class.
No, ma'am.
We,
You take
Lunch.
ma'am, we got a class
Okay, go
again
for
at
lunch.
12
Okay,
o'clock.
okay, we go. Okay, next class we will continue. But the basic theorem statement and all you understood, huh?
Yes, ma'am.
Ma'am, will you be sharing these notes?
Okay, Thevenin.
Yes, ma'am.
Yes, Thevenin's equivalent means one voltage source in series with Z Thevenin. Norton's means one current source in parallel with Z Thevenin. Okay, so first step is you need to find out V Thevenin by opening. Then you have to find out the R Thevenin value by killing all the sources. Voltage source means you will short. Current source means you will open. Okay, these things you remember. These things only will solve problem in next class. Okay, now you are free to go. Now you can leave.
Okay, ma'am.
Okay, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank you. Okay,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay. Okay, ma'am.